So first of all, I want to say thank you to everybody for choosing this presentation. I recognize I have some steep competition with Waffles in 2056 doing wonderful presentations elsewhere in the building. So,
I think it really will sound
I swear I didn't like code this in as a prank. This is going to be annoying, but that's all right. And I can't go to the next slide. There we go. So, agenda today, team organization, project management stuff. We're going to talk a little bit about what an alumni group is, some general safety advice, design parameters, manufacturing tips, wiring tricks, bumper and robot demonstration and Q&A. We're not going to be turning on this giant baguette-shaped robot. We are just going to be talking about it, but we will do a hands-on bumper demonstration of some lessons learned, both good and bad. So, with all of these things in the agenda, our objective, welcome, is to learn a few different things about what we call rookie mistakes in FRC. Rookie mistakes are things that are easily avoidable, but you just didn't know any other way to get the job done. And the best way to avoid rookie mistakes is to look at veteran teams. So frequently I'll be making mention of teams like 4917, 865, and 5406 who've got things figured out. These are three highly competitive teams that happen to be in all in a row there. Why are you laughing? 865 is actually competitive, okay? This is a hill I'm willing to die on. Your 2020 year, you were #1 at your district event, and you won. You got clean blade.
Yeah.
Own up to it. You're a great team. We're going to continue going around asking what team everyone's on. I'm going to skip everyone wearing this same exact hoodie because I was on a bus with all of you this morning. So welcome back, my students from 9062. In the back here, it looks like we've got two people in green. You're both on the same team. Wonderful. What team are you from? 10015. Wonderful. We've got a pre-rookie team here. What's your team name? Bubbles. I love that. And what city are you from? I'm sorry? Aurora. Okay. Another long drive. How was the drive in this morning? Okay. 6 a.m. or something? Brutal. I wasn't even awake at 6 a.m.
Yeah, I wouldn't have been
Yeah, you're from Toronto, right?
I just didn't sleep well. I was supposed to wake up at.
No, you first.
Hi, my name is Brett. I'm from 6135 Arcus, so we're in Toronto. I'm our co-captain, one of our co-captains this year, and basically I do a lot of a bit of everything, a lot of logistical work these days, but previously I do a lot of media and electrical.
Great. Congrats on the promotion. And you, friend, what team are you from?
I'm William from 7902, Markham Firebirds.
William from 7902 Markham Firebirds. You guys have been doing pretty well this season. I love the Quokka's arm. I love that you had a climber on the inside, that when the arm was down, you were able to climb like that. That was awesome. You guys have done a really good job of avoiding some of the pitfalls that are in this agenda. And we'll go backwards on this real quick.
Hi, my name is Eric. I am from 5406 Celtics. I am on drive team, mechanical, electrical, scouting, football scouting as well.
Okay, so a little bit of everything. Peppered in experience from everything. I do also have to know that this man has seen more matches than I will ever compete in my lifetime. And yourself.
Hi, I'm Craig. I'm with Team 3161. I lead media and marketing, and I do basically anything that's non-technical, and then also
Okay, so you said you do pretty much everything that's not technical,
yeah.
and then you listed 2 full things that are technical.
Well, yes, everything that isn't programming or like adding.
There we go. Okay, so everything that's not design or programming. Understand. So a lot of tactile hands-on stuff, and then a lot of non-technical ones. Yourself, where are you from? Okay, so he does most of the other things, and then he's like, hey, can you do the design? Okay, so you're just shoveling work on it. Okay, great. Love to see it. So we're going to talk a bit about team organization. What I recommend for all teams is that you match your organizational style to fit your current members. This looks like co-creating success criteria. This is a complicated phrase that basically means build your goals with your teammates. As a mentor, what this means is somewhat coming up with a rubric for students to come up with within the team leadership of goals that you want to accomplish and making sure that they are SMART goals. We'll talk a little bit later about what a SMART goal is. New roles have to fit student leaders where they are now, not where they're going to be by the end of the season. If you try to fit a person into a mold you had for a different person, it's not going to fit that person perfectly. The way that we tend to run things on 9062 is a little bit more fluid, a little bit more chaotic than what other teams might tend to do. but so far it's been working out pretty well for us. Changing the role expectations to fit the age range of the students. Hello, Steele. Late.
So sorry.
Welcome. Changing the role expectations to fit the age range of the students is important because if you've got a bunch of 14-year-olds on your team and you're trying to get them to do custom like photon vision code, it might not go how you're expecting if you expect a certain level of professionalism out of these 14-year-olds. However, if you've got a group of grade 12s and you are trying to get them to program an FTC robot instead of an FRC robot, maybe that's an inappropriate age range for that activity as well. Clear, concise management styles allow for faster transmission of information. You do not need to hold a bi-weekly vote to make sure who's the captain next week. This leads to a lot of confusion. And this chart, albeit, is the most confusing chart that we're going to see today because it's like a spider web or a crab or something. This is an example case when we were rookie team 9062. With no experience in FRC, we focused our team management more around subject-based subteams rather than interests. Wiring and programming were technically separate as were strategy and design. So this means that everybody who was supposed to fit into a box fit into a box. Each box was the same size. And this led to a bit of confusion. These graphics were made prior to kickoff, so this was actually a pre-rookie's ideal of what the build season was going to be like. Then in 2024, we had some more experienced students. We've been to a few events, we even made worlds, so we've got a lot more experience on the field and a lot more character with the team. We shifted focus to fine-tune interest-based roles. And the reason that we focused on interest-based roles is because students are more likely to do the work if they genuinely want to do it. A good example is if you ask someone to scout for 6 hours and they do not want to scout, they will be playing Subway Surfers the whole time. It will be annoying. So we want to make sure that whatever students are assigned to is something they actually want to do. Allison, our team captain, was given this role due to interest in all sub-teams and her skills in multilingual communication. A great team captain is able to communicate to all members on our team. Our team speaks 17 languages. So what we have to do is we have to find a student who can then communicate between, I see a few agape mouths, yes. Sorry, forgot to preface, we're an international school. So we have 70 different regions represented on our school's population page. We also have about 17 or 18 different countries listed in our team page. So that means that communication can be difficult. For example, we are running 2 drive teams at the Southwest International Off-Season event. One drive team is entirely comprised of people who speak Mandarin, and then there's everybody else. So we will have one drive team where we are speaking English, and then I'm the drive coach who has to, I guess, use hand symbols and 5 or 6 words I picked up in Mandarin to communicate what's going on with the other team. So a team captain is really good at meshing all the teams together and making sure that we know what we're doing. We made this really confusing chart in, I think it was June of this year, to describe how our designs, how our team structure is going to go from here on out. The idea is that we focus on knowledge transfer because we're an international school, we only get kids for a couple of years. For example, most of the students who are here wearing red are in either grade 11 or grade 12. And this means that every year we get Thanos snapped and we have 50% less students. This means knowledge transfer is extremely difficult for our particular case. This won't be the case for CELTEC, so 865, because you tend to get people for 4 years, sometimes even 5 if they take a victory lap. Come on in. You haven't missed anything. We're just yapping. So the roles are shifted more into peer mentorship roles as the grade 12s try to impart knowledge to the grade 10s and 11s, and sometimes rookie grade 12s. Grade 12s pair up with grade 9 to 11s to impart skills. This is focused on skills. So we build kind of a leveling system this year. So in the 3 seasons that we've had, including 2025, we've had 3 different strategies for leadership going into this, clear and concise. First one is topic-based. Second one is interest-based. Third one is knowledge transfer. Very short phrases allows us to communicate easily what exactly the objective of the team organization is. So I mentioned earlier that we want to make sure that our team organization strives for SMART goals. And up here, I have a few good examples and bad examples of SMART goals. SMART goals, as you may or may not have heard from grade 10 business class, they're specific, measurable, achievable, relevant, and timely. So this allows you to have 5 different factors by which you measure the quality of your goal, not necessarily how achievable or unachievable it is. That's just the A part. So a bad example would be, in 5 years, I want to win Einstein. Don't get me wrong, you very well could. I don't think it should be your goal. It shouldn't be like the organizing principle for your team, because what if you don't? There's so many factors of luck that happen at Worlds. Take a look at 2023, 2056 and 254, two best teams by EPA that year in the entire world teamed up. And then unfortunately, due to a malfunction on the field and a couple of bad strokes of luck, they were eliminated within a few minutes. Everybody in Canada was like, oh, that team's going to win Einstein. That's it. That's game over. But it wasn't game over, because even though the goal was Einstein, that is not a SMART goal. A SMART goal might be no on-field breakdowns. That's a very achievable goal if you build simple. And that's a great example that can be found in Team 9098 from this year and last year, Team 3161 from this year, and from 5406 usually has this as their guiding principle. They usually give an entire presentation that Swap tells you how to make sure you don't have on-field breakdowns. I highly recommend you go to that. So, why are developing vision systems and no on-field breakdowns good SMART goals to have? Anyone break that down for us? Good.
Well, developing vision system is very specific. It's like one part of the robot. There's also additionally like the following system. It's a time frame. It's not developed vision systems forever, never, never. It's just for this point, we want to make sure we have this goal.
Yeah. Not only that, it's not encouraging crunch time.
It's not luck-based.
Pardon?
It's not luck-based.
It's not luck-based. There's the key. If you're designing your goal and there's some element of luck in it, redesign your goal. If your goal is we want the robot to turn on, that is specific, it's measurable, maybe not timely, but it certainly is relevant. It is also controllable. Controllable is another thing to break down why these are bad examples. Winning every match is uncontrollable. You could be left with two teams that score -1 points per match on average. They just, whatever they do, they end up mixing their lefts and rights. They end up crashing it inside, getting some fouls, whatever it is. You might not win every match, but you can do your best to win every fight for the center line on it. Or you could try and win every climb. There are very winnable scenarios inside of unwinnable climbs. So, what goals should a team like this set? Let's take a look. We see it here that there are 3 wheels poking out the bottom, so it's not swerve. It is a simple tank drivetrain. And yes, this did pass inspection. What goals should a team like this set? Does anybody have any ideas? Right.
I was gonna say no fouls, but I realize that is luck too.
No fouls has a small element of luck, so how can we rephrase that to be more achievable and controllable?
Like max. Okay. I guess it's more in my experience on my team is communication specifically between the guy team is very important, especially if you have a robot like that. So maybe just like prioritize that. Prioritize communication.
Prioritize communication. Okay, so you can excel in non-technical formats if you are, let's say, a lower resource build. Now, I have done very minimal research into 5246. I've been a fan for years because of this robot specifically. This is a decade old at this point. Let's see what the experts have to say. Dean says they should probably aim for no on-field breakdowns and scoring at least once in a match. I think that's a pretty good goal. It's a smart goal. It's controllable. Let's see what the other expert has to say. He says, good idea. This fits with a lower resource team so they can meet expectations. This robot is good. And I'd like to imagine Dean is asking if you can talk about the XRP robot, but that's a whole other conversation. So, project management is our next topic. This is a bit of a variety hour, so we're taking a left turn. This is a Gantt chart. Has anyone seen a Gantt chart before? You've seen a Gantt chart before. Awesome. What does it do? Exactly. It tells you how much time you have per thing, and it tells you what the next thing to do is. How do we format this in order to collate all the data? Does anyone know how to format a Gantt chart? How do you make one? That's all right. It's a confusing system, and it's usually taught in university business classes or college business classes. But in FRC, this is super relevant because we are on a crunch schedule. We are basically speed runners. So how do we speed run something? We divvy up and conquer those objectives. If we were to take everybody in this room and assign a task to them at kickoff, we would be able to build a robot in like 2 weeks flat. We've got a bunch of really smart people with varied experience levels in various topics. So how do we break that up? Well, on the x-axis at the top of this chart, we have time. The first few days are broken up hour by hour because that's kickoff from 2024. After that, we've got a weekend followed by the AM and PM sections of that following week. So this is literally what we used this year to determine our tasks during the 2024 build season, and it worked pretty well. We ran a Robots Done Quick RI3D style build. We ran a live stream. Everything in green here we got accomplished in the time frame required. This one ended up falling through, but that was not for lack of trying. So we can track our progress with each one, color coding it to match whether it's been completed or not completed. Or alternatively, I've seen some people blot out in black each thing that they've successfully achieved. Each thing is labeled with a color and a short form. That way you can determine where you are on each map based off the topic or sub-team that you're a part of. For example, I've heard some people that are on the coding team, like Min over there, he would participate in the green items here on the board. So here's an example of the workflow for a design team member during the build season. It would start off on kickoff at noon. We watch the broadcast as a watch party event. It's kind of like a live stream that we all tune into at the same time. My team, we like to get together as not quite a watch party, but it does definitely feel more casual. Throw around some ideas, have some game predictions before the actual unveiling of the game. Then by 2 p.m., the live stream's over, we've had our lunch, we come back and we do a rules analysis, and we figure out whether we're going for points or RP. This is a very important conversation to have in the modern era. Since 2016, RP has been up for debate whether it's more important or less important than points. And certainly this year, there was a change in meta halfway through the competition season. So we like to spend an hour or two talking about that. Make sure that we've done our analysis of the rules, we understand what's required for the robot build. Then in the following 6 hours, we do a fabrication live stream that does not concern the design team. We modify the drive team trained CAD. Usually we'll do a CAD-a-thon or something and post it on Chief. That way it's open source and available for reuse before kickoff. Finish the belly panel CAD, and we were at Tuesday evening. Tuesday evening, we can send off to our manufacturers exactly what we need. For example, I know that Tronic, Titans, and a couple of other teams in the crowd here use Sable Metal Manufacturing as a sponsor in order to get all their sheet metal done. What's the lead time on that?
2 weeks this year.
2 weeks? Okay, so if you get it done by the Tuesday after kickoff, that means that you could have a robot built by Wednesday.
So we gotta go.
Pardon? Week 3 or week 4 build season. That's great. That gives you 2 more weeks to, oops, I assembled it wrong, and let's do some drivetrain. Because there's always a week of, oops, I assembled it wrong, right? Let's take a look at the workflow for another subteam. Partnerships would participate in these events up top. This is for everybody on the team. But then they break off and do their own thing, and these arrows indicate the workflow. Additionally, fabrication has a much more complicated schedule, and as such, I've added 2 slightly different colored arrows to indicate 2 different teams. So for example, if I am on this fabrication team here, I watch the live stream, make sure that it's operational, I participate in the robots in 3 days build, and then for a while, I head back over here and fabricate the 2x1s for the chassis on Tuesday morning. That way, the design team has already designed the belly panel and sent it off for manufacturing. I know how big those drive rails need to be to assemble our swerves or our tank West Coast drives. And then I can switch back to the live stream in the evening before finally ending up on fabricating bumpers. Because if you're the one to measure and cut the 2x1 drivetrain for rim rails, you know how big the bumpers need to be, and you can immediately start working on that without communicating to another person. This means that they can get like 4 different tasks done in less than a week. So it's a super complicated setup, but I highly encourage teams to take a look at Gantt charts and make sure that they understand how to use them to their strategic advantage. Using Gantt charts, we could delegate and conquer the new 2025 chapter, whether it's a water game or not. By the way, did you know that you can use Onshape inside, like you can link the tabs? So you can actually insert your Gantt chart into Onshape. There's the Onshape logo up there. This thing called Link Tab, it is a bonus, and you can just use Link Tab anytime you need. It's a DLC, similar to how MKCAD can do stuff. The next topic of note is alumni groups. So a great way to pass knowledge between years of students is to establish a tight-knit alumni group. A great example of this would be Fanshawe Engineering or Western Engineering, both based in London, Ontario. Both of them have an ongoing group of alumni from various FRC teams that get together every once in a while to do a casual FRC style event. The top right picture is a 230-pound automatic t-shirt Gatling gun that they built in 6 weeks. This was 2018. It was a lot of fun. I actually participated on this build. The range was pretty significant. You could get 150 feet with these t-shirts. The reload time was horrible. So a lot of lessons were learned, and that knowledge was then transferred onto their own team that they founded, Team 6856. Finding an annual activity to do with alumni for your team is a great way to keep them involved and keep them coming back and then giving their knowledge back to the next gen of students. For example, if I were to ask Lucifa, which alumni do you recognize coming back to help us out? Williams did come by, right? Sharir? Shaq's been by 3 or 4 times, yeah. So these are all the names of people from our team that have graduated in 2022 or 2023. They're now coming back every once in a while just as visitors to help us out. This has been hugely helpful because that means I can then turn my attention from programming over to something I actually know about. From a post-secondary mentor team such as FIRST or Iron Falcons, it's super important to create a solid foundation of dedicated people at the university level. This is really hard. McMaster's been struggling for the last couple of years to try and get the mentorship team up and running. If you know anyone at Mac, please hit me up. I would happily help them to form a mentorship team. And having alumni assist with kickoff, competitions, fundraisers, 2056 Ways to Inspire, perchance, all of these events can be made possible or more achievable for a well-resourced team if you have a stronger group of alumni, because it's an effective way to boost your numbers. Make sure that it's low commitment for your alumni, fun, and it can help teach new student interest. So the bottom right is an RA3D from 2024. RA3D, for those uninitiated, is the Robot in 3 Days speedrunning community. It's a lot of fun. I highly recommend it when you graduate. Just a quick side note, we're going to turn left into safety. This is a lot of safety gripes that I've seen over the years with rookie teams or non-rookie teams acting like rookie teams. The average team has a safety captain, but their role on the team is frequently diminished or undervalued. That's a problem that I've identified inside of the FIRST Ontario community specifically, is we don't do a great job of celebrating our safety captains. We used to be industry leading across the world with the UL rating for the safety captains here, specifically at the Waterloo event, but also all across Ontario. And a great way that we can transfer that, into the modern era is to make it a bigger role, equal to a sub-team lead or a captain. Safety is important, and safety can then be seen as more of a priority rather than an afterthought. This gives students a certain sense of pride when they become safety captain, and it leads to more engaging discussions about how to improve the classroom or whatever your build space is. Red, let's put you on the spot. What are some safety issues with your lab?
It's not our room, and
It's not your room.
Well, we can't use most of it.
Can't use most of it. There's HVAC sheet metal.
HVAC
There
metal.
is
Oh, we've got a dead
wildlife.
mouse. We've got
There's
a dead
wildlife.
mouse.
I heard about the raccoon as well.
Oh my gosh. So the food was living in our space during the winter break, and also we just cleared out a wood pile, and there was a dead mouse with the fur literally stuck to the floor.
Oh, okay. Maybe you shouldn't have said that last bit out loud.
Yeah.
That is rough.
I wasn't there, so that's
So,
okay.
who's your safety captain?
We actually no problem this year.
How can we make that situation better?
I think Joel and I probably stepped into more figure that role and justify that.
Great. So having the co-captains initiate a talk about safety is good. Maybe you could get a grade 9 or a grade 10 to take the role of safety captain and encourage them to then bring issues like that to you. And be like, hey, this sheet metal is too sharp. Can I go sand it? Something as simple as that will make your lab a lot safer. Thank you for letting me put you on the spot.
Arctos is weird.
Arctos is weird in a good way. It allows for these discussions to seem a lot more natural rather than me coming up with a random example. So safety captains should co-create the safety rules. This is a very key thing. On my team, the only student who can boss me around, and they do boss me around a lot, is Bella, the safety captain. This is important because it puts me in my place when I'm doing something unsafe as well. The safety captain should be a place of priority and of gusto. You should have someone who is confident and capable in the safety role. And you can help to train someone to be that way by making this role seem like a big deal. This makes the student feel more in control of the job on their team and a sense of pride and confidence can be built over time, rather than just assuming the student's going to be confident. Design parameters. Here's a CAD of a robot that is not visible on the screen, but it is just off to the side over here. This is the world's widest tank robot. Don't do this at home. Objective versus subjective design. Does anyone know what objective or subjective means when it comes to designing robots? See? An opinion versus a fact. Okay, so we're analyzing that from an English literary side. That's pretty close. Objective means we are designing a robot to fit the parameters, not our budget or inventory. Subjective is what do we have and how can we turn it into a robot, which is very much the early to late 2000s model of FRC. Here's a box of stuff, turn it into a robot. How can we marry these two subjects together so that we have both subjective and objective areas of interest in mind when we design things? Well, we can take them both into account. Doing a deep cleaning of your lab before kickoff is a great way to establish an inventory or to update your inventory system management. And with bigger teams like Celtex, they have a bigger part to play with inventory management, as there's usually a mentor who can do all the purchasing, or a mentor who at least knows what they have. For a team like us, I don't know what's in the storage room. Let's go find out. So a deep clean is a great way to remind me and my students of what's available for build. This helps handle the subjective part of design. What do we have? How can we make this robot effective, but also less expensive? And if there's a bunch of stuff in the lab that we're clearing out anyways, let's give it to some of the rookies. Objective design comes more in clutch when it comes to sheet metal design or custom manufacturing. You've got access to advanced machine tools like 3D printers, TPU printers, CNC machines, or mills. This allows you to not so much rely on what you have, but on the raw stock that you have, and how you can take those forms and make it into whatever you want. So for a team like 865, who has lathes and mills at their disposal sometimes, all the time, great,
We got
love
a new
that.
mill. It was like 8K.
Dang, congratulations,
Yeah.
that's awesome.
We don't have electricity yet though, so we might not be able to use it for the
Just get like a niner to run on a little hamster wheel.
season.
You'll be good. Set up a food station. Like the Ontario Science Center used to have that bicycle with the light bulb. You just like get 10 of those in a row, you should be good. Or solar panel, whatever you want.
No, like we got a new lab. We're in a new lab this year, so
For real.
yeah.
Congratulations.
It's just a different thing.
Still, that's an upgrade. An upgrade is an upgrade. Is it a bigger room or is it a smaller room?
We have less storage, but it is a bigger room, and we have space for like a half-life campus. They're like
Well,
quarter size.
if you've got more room, you have more room to build more storage, right?
No, like square footage, it's smaller, but like it's more open.
Great.
Yeah.
Okay. I know that some people build out of classrooms that have like the tables are bolted to the floor, and that makes it really annoying for practice. So it sounds like you've got a great open space.
Yeah, it's like only used for remotes.
Awesome.
Yeah.
I love to hear that. It's awesome to hear these positive notes from like, oh yeah, we're a team that's been around for a while, and now we've got this great upgrade that's been level us up. That's awesome. So being able to then design objectively with that new lab you have, maybe a fancy new lathe that you bought, means that less barriers for entry to certain designs. Don't build a turret if you only have a hacksaw. But build a turret if you have a CNC machine. That's on the table. That's fine. Don't do custom swerve unless you've got a CNC sponsor. Because even if you have a CNC in-house, that doesn't guarantee the tolerances you need to make custom swerve. Fail fast with prototypes. This is just a quick note. If you're doing prototypes, it is better to fail quickly than to succeed slowly. Prototypes are supposed to test the concept, not actually the materials that you are intending to build with it. Don't make your prototypes out of aluminum. It's just going to cost you money in the long run. Personally, we use plywood and cardboard on day one, and we use sketches on a whiteboard and some on-shape crayon pad to move forward quickly. Two debates usually happen around kickoff for the design parameters. One of them is RP versus points. Is it more important to rank high at an event and pick someone who can score, or to score better and hope you get picked? That is entirely subjective based off of your team's design parameters for the season, and that's a debate worth having prior to kickoff. Don't have this when you are building the robot. For example, we're planning to have this on the last day of school for this semester. Our semester ends right before the winter break, so that gives us time to plan out exactly what RP looks like when the new season comes around. Ground clearance and maximum height is debate number 2. how much ground clearance do you need in a post-swerve era season, and what is the maximum height you can go to? This often, those two things coupled, figures out your center of gravity concerns. If it's like 2023 and you have a 4-foot extension limit and you have a 4-foot height limit, you should be worried about center of mass. If it's 2024, you don't need to worry so much. You can keep everything pretty low without stretching your design. So the design parameters might actually limit based off of the center of mass, the ground clearance, the maximum height, the basics like that in the rules. And debate number 3, which is a bonus, it can happen after kickoff, that's fine, is the electrical panel there. I know a lot of teams like to do an inverted belly panel, some of them like to do a normal belly panel. Right, which one does your team tend to use?
This year's we do a belly pan. This year decides to structure rain pan.
Rain?
Well, that's what we call it.
Tell me more.
Why did we do it?
So it's like a vertical plate instead of a horizontal. Great. That's what we ran with this season as well. So we call it an inverted belly panel, but you guys call it a brain panel. So mentally, just cross that out, and you can put in brain panel if you want. Whatever format for your electronics. I know some teams who like to decentralize their electronics because it makes for better troubleshooting. I personally disagree with that, but it's your team. Design team works on the rest of the information after kickoff as individuals. This is the only stuff you need the full team for. After the team has come to a consensus, not a uniform agreement, move on to design. You do not need to spend a week with every mechanical student saying, let's build a turret, or let's build a 3-axis machine arm so we can claw game the game objective. Sometimes you can decide on objectives pre-kickoff, like what kind of drivetrain you want, whether it's swerve, tank, H-drive, I-drive, Kiwi, whatever else. Belly panel material can also be chosen. If you have a sponsor that only makes steel, you might want to consider using a steel belly panel because it can save cost.
Well, just for the previous point, wouldn't it sometimes, I mean, like, obviously you can decide for a drivetrain beforehand, a drivetrain beforehand, but what if it's like a game like 2016 where swerve would not be ideal? And you choose swerve, but then...
That is a very valid point. So the question is, what if it's like 2016, which is notoriously very difficult to cross with swerve? Is it a swerve killer game? And I'm of the personal belief that FIRST wants to encourage swerve. From what we're seeing, it is far more marketable as a extracurricular when the robots move fast and they look really smooth. So having swerve actually boosts the amount of new teams because they see that, they get inspired, they want to join. So personally, like, you call me a conspiracy theorist, I don't think it's going to be a swerve killer next year. I think it's going to encourage swerve again. Like 2023, there was a bump. It might kill some swerves since the center of mass was too high or if you built it wrong. But for the Mark IV Is and the Mark IV kits that are coming out now, you can still do 2016. 2016 is a very achievable swerve game as long as you slow down before you go over, which is the key, right? And also the bumper rules were different back then. You could have high-centered bumpers so you wouldn't have to worry about ground clearance so much. You could even have treads on the front or an impact plate to help lessen the weight. You can use other factors to then navigate around that objective. And it saves you the headache of going, okay, then if we're doing West Coast Drive, how far apart do we want our wheels? You can choose that beforehand and then just have a quick 5-minute conversation after kickoff being like, are we still doing West Coast? Yeah? Okay, cool. And then the design team can go off. That's a great point, though. If you want to organize your team that way, all the power to you, if it works with your group. If you're finding that you're moving along slowly, though, that might be a way to speed up the conversation.
Yeah.
Have
No,
a
we usually
pre
do.
and a post.
I was just...
Great. Yeah, it's a good point. 2016 is always on my mind. It's one of my favorite games.
Yeah.
Encouraging designers to look at older, similar FRC games for inspiration is key. For example, 2056 has every robot they've ever built in storage ready to use. They don't take their electronics off and leave every sensor on there. And that is awesome because it means day one they could be driving around with a similar robot from the previous year. So let's say that 2025 is like 2018, and we just stack cubes on a weird thing. Doesn't even matter what it is. 2056 could just pull their 2018 robot out of storage and start driving. Obviously, the average team does not have access to that kind of equipment. But we can take a look at designs, whether through FRC Tracker, which is an old app that still updates, or just Google Images from those previous games. We can take a look at Robotics, figure out the most effective 2018 robot out there, and then interpolate that to fit the 2025 rules. Some manufacturing tips for anyone who is just getting into more complex machining. You've already built a kit pot, let's say, or you're intending to build a kit pot. Here are some design considerations when it comes to different materials. Those of you in my grade 10 class, I think I've got 2 or 3 who are on this trip, you will be very bored by this slide, but that's okay. So ABS versus polycarb, those are 2 different kinds of plastic. Polycarb shatters, ABS bends. I encourage you as teams to figure out which one you want to use in certain ways. For example, if you're doing an over bumper intake in 2025, please make it out of something that can bend back. Polycarb shatters when it's hit at the wrong direction at the exact right angle. That angle is random based off of the design that you made. So if you have a wonderful half-inch polycarb arm that weighs 20 pounds, go for it. That's what we did this year. It worked out well. But if you're making it out of 8-inch polycarb, you might want to consider something more flexible, like the UHMW or HDPE solution. These are all purchasable from McMaster Car for about the same price. So when it comes to designing things, you might want to consider exactly what it is your forces are going to be distributed against. Countersunk drivetrain bolts, can't recommend it enough. Bumpers are easier to fit if the entire thing is smooth. So I'll show you in a bit when we come to this bumper. There are some issues with fit and finish that happen because we're using rivets instead of flat head cap screws. Rigid riveting. Again, I highly encourage people to take a look at Team 1538 for inspiration or Team 2056 as per usual, because riveting is important and using a star pattern to rivet helps you out. Yeah, there we go. So limited fastener selection. This is something that we piloted this year, but we're definitely nowhere close to the first team to do it. By limiting the number of bolts, the different sizes, diameters, lengths, etc., that you have at your disposal, and then using those subjectively in the design choice, means that you have less that you have to pack for competition and less you can lose on the feet. If every bolt on your drivetrain is a 1032 socket head cap screw, that means that anytime you need to get a spare for your drivetrain, you go to the same bit in your line. You can keep everything organized. You're not going to miss out on much. For example, on our team, we have 4 different sizes of diameters for all of our fasteners. We keep 3/16, which translates to a number 10. We have a few number 8s, but it's not official. We have 5/16 for all of our bumpers, and we have 3/8. And 99% of our bolts are covered with those options. This means that all of our prototyping, all of our builds can be done super fast because they're not looking for bolts. Additionally, bushings and bearings. Know the difference? Pick which one works for your team. And this was a request I got from a member of 2056. He was like, the only thing that I regret about our team is that our sponsor panel kept falling off. So I wanted to put this in for Balraj in case he's watching the VOD. So the sponsor panel assembly. How can we improve the rigidity of a sponsor panel? Has anyone built a sponsor panel before here in the room? Anybody? All right, William. How might you solve the problem of every 10 matches your sponsor panel falls off on the middle of the field?
Personally, my team would tie it down and use VHB.
Zip tie and VHB. Okay, VHB tape has earned the nickname God tape because only God can undo it. So if you want a sponsor panel to go on and never come off, that's a great selection. Great way to solve that problem. What if we want it to be removable so that we can access things like a pneumatic cylinder or some sort of sensor readout? How might we solve that problem? Right.
It's similar to zip ties, but we also had oh my god, what's it called? Velcro.
Velcro. Okay, so
Yeah.
this is exactly what 2056 uses. They use the Velcro for kit parts on all of their sponsor panels. This makes it super accessible. They get unlimited amounts of it because it comes in the kit every year, whether you like it or not, and you can reuse it hundreds of times. You can rip it off. But after number 200, the Velcro doesn't stick so well anymore. So what then? If we have 200 matches, that's a whole nother problem. We're playing too many matches with one more time. But let's consider for a second how to solve this. We could add piano hinge and pull pins so that we pull out 2 pins and open it like a door. That way we never actually need to remove it fully. We just need to move it in there. We could build in drawer slides so we can slide it open like a door. There are many different options for solving this problem that fit your particular robot that you're building. You want to make sure you have sponsors on there so that you get some funding to help pay for all your cool robot parts, but you also want to be able to access your systems on the inside. So, exchange hook and loop for pins, hinges, or rib nuts. Rib nuts are really helpful. Does anyone not know what a rib nut is? I can go over that. Rib nuts. Okay. Riv nuts are a little bit more complicated. It's a rivet that has an internal thread like a nut. So when I use a rivet gun and I rivet into a thin sheet of aluminum, it produces a seal. But that seal can then have a nut on the inside that you can bolt into. So it's essentially like installing a nut automatically on any piece of metal that you need. It's super helpful. You require a special tool for it, but it's really not too much trouble. So if you want something that can be boltable and unboltable in multiple configs, let's say a 2015 can grabber or a 2024 sponsor panel, bolting it on with an impact driver and some rib nuts is a great idea. Now on to everybody's least favorite topic, it's wiring. So you can find some examples of Wagos and vampire crimps on Baguette, the world's widest tank drive. We'll go over that in a minute. But we have Wagos for prototyping, vampire crimps for canning, and soldering where it makes sense for your team. So this is where I reached out over Discord to a couple of teams in the area, including our host team 2056, to see what kind of electrical methods they use to ensure that they don't have can issues. Because when I was a rookie, or when 9062 was a rookie back in 2023, we had can issues every 3 matches, and we couldn't figure out why. Until we realized that we were doing our can bus with Wagos. Wagos are excellent for running 12-gauge power lines to motors or motor controllers, but they are absolutely garbage when it comes to holding in CAN bus connections under pressure. If you jiggle the wire a little bit, Wagos sometimes disconnect. And that hurts when you're going over a balancing beam at 20 kilometers an hour. So I highly recommend investing in some Wagos if you're a rookie team or a developing team. This is great for prototyping. This is great for power lines. You can leave it on the power lines all season long, no problems. There's even zip tie holes in the middle on the fancy ones. However, the top picture here is a very cheap ad from Amazon that shows exactly the thing that I use for CAN bus. So if you're interested in a low voltage wire connectors, solid connection, T-tap wire connectors, T-type 2 pins, wire splice connectors, look no further than Amazon. It allows for the yellow and green wires to be clamped onto like Mu Dang, and it won't let go ever. So this means that you don't lose CAN bus connection ever. We have not had a CAN bus issue since 2023, and I was so happy. I did not think I would read out that whole thing. Soldering where it makes sense for your team. So if you have something that you want soldered, go right ahead. Just make sure that somebody is properly trained. A bad solder connection is worse than a wing.
I have a question. Do you know what else, like what specifically would you solder? I think you've soldered some things, but like what would you ever do?
So for our team, I solder as minimal as possible because I'm not great at it, and we've got some grade 10s and 11s that are pretty good at it. Amy, you're pretty good at soldering actually. Put you on the spot. But what we do is we solder any sensors that you need, like a CAN coder. So rather than paying the extra $20 for Steele to solder it, we bring it, we put our own wires, and we solder it ourselves. Saves money. I like that. It's my credit card. But everything else for our team is using the vampire crimps and the Wagos. We also have translated over to Anderson power poles on all our motors and motor controllers. If we're doing longer runs, we'll use Wagos if we run out of APBs, but Anderson power poles are the #1 way to secure that. I can't stress that enough. I think in this picture, even though it's like 1 megapixel, you can see a few Anderson power poles at the back behind the victors. It's like super zoomed in. You don't even look that closely. It's like a Where's Waldo, but from 254 in what I can only assume is 1990. Give reasonable slack for organizing. So in this example here, we've got a waffle pattern made popular in Canada by Craig and Toronto Titans over here, as well as Celtex, who's also another one. These are 2 teams that do this waffle pattern so that they can zip tie in 2-inch or 4-inch increments along a wire drive train. This is super helpful. We like this. We want to see more of this. So it's time for our bumper demonstration. I prefer V-style plates. I'll show you what V-style plates mean in a second. It's a common fastening method among swerve teams. It's highly recommended for side loading, which is what bumpers get. It's not very often you come across a robot that tries to take your bumpers off by doing this. Very often you get a lot of this, a lot of rotation, a lot of side pull. Other mount styles include gussets, L-channel, and milled blocks. I've spoken to a few different people in the FRC community, and I've come up with this handy chart. It looks super boring, like it was made in the 2000s, but we're going to ignore that. L-channel here is just adding an L-channel on the inside of your bumper and then placing it horizontally and bolting through it. This is what AndyMark recommends for the AndyMark AMI 4U. It's very simple, scored high on simplicity. It's very robust. Not often it breaks down. But you have to be pretty accurate, and it's pretty slow to swap. The best option here is either clasps if you are able to build complex mechanisms, or V-plates if you cannot. So I'll show you what that is now. For those on the stream, I guess, good luck. Oh, we've only got one viewer on the stream, that's fine. So here we have the world's longest sort of, and I'm going to take off this front bumper in like 10 seconds, if it works. You keep in time. So why am I not able to take this off? Well, it's because it was made by Greg Knox. But that is pretty robust for 2 bolts. It took me 10 seconds to loosen that and another 3 seconds of shuffling to get it off. And this is the #1 method I recommend. We can see here that there are V-plates on the front. These have been riveted to the 2x1s directly. That means that any side loading here or here gets translated between the two and makes for a stronger fit. This is something that Team 4917 has been doing for years. You guys got this. You don't need to listen to me. You can play in Temple Run. Actually, I don't feel like wrestling with that. I'm just going to do that. Inside, we can also see some electrical. So this is part of the conversation where it becomes more of an open table discussion about what you want to learn from each different team. So some fasteners that work well with this are the winged nuts that I was using on this plate here. They've got a tiny flange, kind of like a washer. It works super well for distributing the weight. Additional things to keep in mind are the rigidity of the noodle selected, their technical knowledge for pick the right cool noodle. I don't want to see the flour ones I kick off ever again. These things are solid, and it allows us to handle more impact with less compression. It means that the numbers on the side are going to be easy to read. Defense is hard to escape from this, so if you construct it with the solid cool noodles, you're going to be better built for defense. If you want to be more on offense, I recommend the standard circle with the hole in it. Also, the ruggedness of the fabric. Pick Cordura or corduroy or something similar, super strong, like a canvas-like material. It's going to be easy for you to put numbers on, easy for iron-on transfers, and it's not going to rip. So, take a look at how this is wired. Feel free to come up and take a look at this. Does anything seem off? Come on up. By all means, if you haven't seen this thing before, it's crazy. So, I'll describe it for the one viewer back home. We have a 53 by 6.25 inch drivetrain here with a 2-wheel West Coast drive. It is powered by 2 Sims operating in 5-to-1 ratio, and it is janky as heck. Does anything seem off? Those wires sticking up? Yeah, so those wires exit the frame perimeter. We don't want that. That means they're more likely to get clipped at 30K by Celtex driving past you. I'm just putting you on the spot because I know you.
It's the fact that the VRM's on top of the PDP.
The VRM on top of the PDP, except what if I told you there's God tape on there?
Oh, okay.
Meaning I will never get to use that PDP again for swerve. What else is wrong?
Well, none of the motor controllers are secure at all.
None of the motor controllers are secured. We just shoved them in there. And the radio, too.
Oh.
So what's wrong with the radio placement being at the bottom of the robot? Works for terrible signal, exactly. So this is something that we did on purpose to test the theory that it was terrible signal. And we got a terrible signal. Myth confirmed. What else is wrong? We got a bunch of PWM wires that were not spliced to the right length. That's okay, but the way that we handled it could have been better. This was a great learning opportunity for my grade 10, grade 11, and grade 12 class, so we could understand different design elements, different fastener types, and different kinds of electrical connections. However, there are a few obvious glaring difficulties that you should not include in standard FRC design. For example, a hand-tightened quarter 20 holding on the e-stop. Don't do that. That's dumb. We only did that because we forgot you needed an e-stop, and so we didn't CAD it. Every other part of this robot was actually designed. I know it doesn't look like it. That's the battery strap. So the battery strap actually worked 100% of the time. We were able to tip this thing over. We were able to jangle it. I didn't feel like carrying a 13-pound battery in just for a jangle. So it is back home. But that part actually worked. There are a few other things that we wouldn't want to do again. Putting the motor controllers in a spot where we can't debug them, making 3 belly panels when we could have just done 1, maybe thickening the handles so that we didn't have as much force in one spot on our hands while we were lifting it. There's a variety of problems. Let's see what the experts have to say. So, for example, the radios under the PDP, I just found the oldest picture I could find. The motor controllers are loose. The RSL is too low to the ground and cannot be over the bumpers. The Rio is vulnerable in a spot where it's attached by only 8-inch polycarb. And the battery wires are vulnerable. And the main breaker's in a weird spot, too. Expert number 2 says, that is indeed correct. Many items are unwisely located. Can you think of anything this robot does well that we can apply to other robots? Battery worked. Yeah, the battery mount was awesome. No complaints on that. It follows the same format as the AMI4U, in that there's a battery strap that goes around and moves back. This is awesome. I recommend it for anyone doing a vertical battery pump. Bumper mounts worked great, as long as the bumpers are made properly. We had a bit of a tolerancing issue when it came to wrapping the fabric that made attaching them a little bit difficult. But in concept, we're able to transfer that to any other robot we build in the future.
I guess even though you can no longer ever use a PDP, it's a physical space, and like you can't see the motor controller, but it's clearly like it's clearly like this.
Actually, I'm curious to see if it is VHB or whether it's hook and loop. Let's find out. Oh yeah, it's hook and loop. Great. Okay. All that talk about it never coming off, and it's removable. So that's cool, I guess. Yeah. So there's a few different positives. We can see on here that the West Coast Drive portion worked fantastic. Turns out you're able to run a Max Planetary on West Coast Drive, direct drive from Ascend, and nothing wrong happens as long as you use blue bot tape. I forgot the first time the wheel fell off. And the shaft at the same time. That was annoying to fix. Another thing that this does well is it keeps the center of mass in the center, front to back, because it's not like it goes anywhere else. Let's see what the experts have to say. William Neal says, I can appreciate the simplicity of baguette in code, and the VRM is nested with this. And Karthik says, the handles make for decent lift points, the strategy is lighthearted and keeps kids engaged, and the stabilizer arm is a creative way to avoid complicated balancing routines. We had to remove the stabilizing arm to fit it in the car. I do apologize. They kept it simple.
What is the stabilizer?
So, I can show you that now. But one more comment from an expert. Oh, come on, this robot is ridiculous. Why would you make, you know what, at least the bumpers are solid. I'll show you what the stabilizer arm is. So on the bottom we have a hexagon. This is a hex shaft from a window motor, and it allows for a UHMW spike arm to pop out at the beginning of auto, meaning that we don't need any stabilizer code at all. We drive it like a normal tank drive, and it essentially has one of those wheelie bars for the back of a drag racer to stop you from flipping. It actually worked. The only issue is we designed it in a way where there was zero tolerance for the diameter of the wheel. So as we're driving, it high centers itself because the wheel is less than 4 inches. So in the future, we're going to make a skinnier arm, and that will solve our problem. But for now, it's interesting. So let's see what time we at here. Awesome, we got loads of time. So, is there any questions about this robot or the concepts that we've talked about today so far? Really? Weirdest robot you've ever seen, and nobody has a question? Right.
What was the most difficult part about making it? Other than like what was just the most difficult part of it?
I don't know. That's a good question. Teresa, do you have an answer? You helped to make this. What was the hardest part about wiring? Probably drilling those holes, right? Yeah. So we've got holes next to the PDP that allow the wires to go inside the frame, but inside the holder for the PDP, which meant that we had to do a guess and check method 3 or 4 times, unwiring it, checking that the wire fit, and then drilling a bigger hole. And that was 2 days. That was 2 days we worried about that in class. That was 160 minutes of my actual real job was spent doing that. Yeah, so that would probably be the hardest part, other than getting code to work, because we had 0 people with code experience on FRC trying this out. People who've taken ICS3U, and we just popped them in and said, here's a YouTube link to 0 to Autonomous, go. So we spent 3 days on that, and then we had Drive. It was pretty simple.
How does it drive?
How did it drive?
How does yeah?
I mean, I don't know what the internet connection is like on this ThinkPad from 2013, but we have YouTube Shorts of it driving around. We have cheap posts. It works. Is it good? No, but
Okay.
that wasn't the objective. It's two sims. We didn't design it to be
Yeah.
good. We just designed it to be fun. And then along the way, we learned a lot of good things. So, I don't think there's a ton of other questions. Thank you for your attention. Any remaining time now, we've got about 30 minutes, can be spent helping your respective teams with any of the concepts that we've learned today. So now it turns into a bit of a roundtable discussion. You're welcome to leave at any point, but we're going to focus on how to help the teams who are in this room right now, improving on these different traits that we've talked about, whether it's team organization, bumper mounts, wiring, vampire crimps, whatever.
I'm interested because ARCUS is very structured and we have not changed, well, the structure changes a little bit with the specific lead position every year. But I'm interested, it's very holistic the way that you change relationship for others to. How do you think I can apply this to ARCUS? Because it is so structured.
How often do you vote on things?
Once a year.
Once a
We
year?
could do it more, but we bring it up last time, so you have to wait a year to talk about it.
So
Unless you want to talk about
ARCUS
it.
is in a unique position in that there is no centralized mentorship. So you cannot ask the adult in the room to make a call for you. And that means that voting has to occur at some point. And I like the fact that it's changed into once a year. Back when Julie was the leader of that team, it was more like once every 3 months. You would vote on who's going to be the sub-team leaders. How are we going to organize ourselves?
Really?
Yeah, there would be like by-elections. It's crazy.
Hey, we had
The
one
lore on
by
your team is actually awesome.
I don't
You should
even
give
know
a
the lore,
presentation
though.
next year. So, yeah, the way that Arctos, I would heavily recommend finding a way in that you don't need everyone's approval to do a thing. For example, if you wanted to build a drivetrain with certain dimensions, who needs to approve it on your team?
Probably co-captains mechanical design.
3 people. So that's
Four.
probably 4 conversations, or at least 1 hour-long conversation, right? Because I get that you're organized. You and your co-captain have been doing a pretty good job on social media. You seem like a very organized crew.
Oh my gosh.
But that's at least 1 hour where you need 4 people in a room with 4 students. That is a long time to try and coordinate those schedules to fit. Because you're also a top school, which means that everyone's trying to get 100%.
No, we're better. We're like 95.
I'm wondering how, like, I don't know how to phrase the question, but it's like, I feel like our team really struggles to get people to stay.
Okay, what do you
because-
mean by stay?
Well, okay. The only reason I stayed is because I was really determined and stubborn and wanted to do stuff. But like, I know a lot of people who, once they come in and they just kind of are like, they leave because, and it's fair. Like, I would have left if I didn't like already put so much time into it. Like,
So you're staying around because of the sunk cost initiative?
kind of, yeah.
Okay.
I mean, I do love it.
You're like,
and I do
I've made
love
it
the
this
people.
far. I've got to keep going.
Yeah, kind of. Like that was more last year. Like
Okay.
this year,
That's
know
unfortunate
what-
that was the motivation, honestly.
yeah. It's just also I feel like I don't know how to get my team to listen to other people
Other people outside of the team or other people on your team?
on.
Okay. So what's the leadership structure look like on your team?
Last year we didn't have a captain.
Okay. Great start.
Was not. I didn't
Hey,
agree.
we were rookies.
then-
We didn't have a team captain at all. That's fine.
And then this year we do have a captain, even though it's really weird because the year before, in 2022, the team agreed that there should always be a captain and there should always be 2 captains. The
Mhm.
next year we had two co-captains, and the issues with our team wasn't because we had 2 co-captains. I think that made our team better. And then the next year we just went fully no co-caps at all.
And you've also had a lot of mentor changes in that time, right? You've
Yeah.
had Connell sort of come and go. I don't know how dedicated he is anymore. You've also had
I think he's in.
you've had a few other alumni come into the picture as
Yes,
mentors.
Seth is basically our only like consistent mentor, at least.
He's a very reliable guy.
Oh, and he is a very reliable guy, right?
For sure.
Like, I think he's kind of just everyone's pillar of like FRC knowledge almost.
So
'cause he's been,
so when you have a disagreement and you wish that someone would listen to someone else on the team, do you go to him and be like, hey, I need this kid to talk to this kid, can we make it happen? Or is it more like, man, I really wish I could go to somebody else.
I feel like we're supposed to go to Mr. Wing, and he wants us to go to, like, Mr. Wing wants us to go. I'm more, it's just like, our leadership meetings is just an hour of bickering, I feel like. And, like,
That is
usually,
so common. That is so common.
I don't know how to,
I feel it like you.
no, we start with one point. Like, I noticed it a lot last season. We start with one point.
Mhm.
We have the hour slot to talk about it.
Mhm.
And then everyone is like playing the devil's advocate, like what if, and then at the end we end up at the same place we started. Like when we tried to set our goals last year, it was like, well, we want to make it to Worlds, and then it's like, but that's not a good way to set a goal. But we still want to make it to Worlds. But then how do you make the? It was so confusing.
But his World's a smart goal.
Yeah, it's like it was so confusing, and it took that hours, and then we didn't end up actually making a conclusion. Like,
Yeah.
And we had the same conversations for like 3 weeks, and we just ended up being like, our goal is to make it to Worlds.
Okay. So
we had like 3 hours at least of just talking about the same thing, and there was no conclusion. I don't know.
man, that is rough. I'm sorry that you had to go through that. So the way that we tend to organize stuff on my team is because I'm the only mentor on duty, I end up getting the final say on a lot of things that normally people used to do on more formal mentor teams, or the Google mentor vote. I've been on teams where there's 7 or 8 of me that then have that kind of argument behind closed doors. The students don't know about it, but sometimes the mentors have that exact same confidence. We've been arguing about this for 3 hours. Just pick an event. Where are we going?
Yeah.
Get me a bus. We'll go. Doesn't matter. And then someone's like, North Bay. They say no. Nothing. If the one, I can say we have one viewer. If you're from 1305, I'm sorry. Please don't at me. All right. You've got my email now. I'll apologize formally. But that's far. It's far. So, yeah, I mean, when it comes to meetings like that, one way that I tend to shut down the devil's advocates is the devil has enough advocates. Advocate for yourself. Figure out what you want. And then say it. And then don't add flowery language. Just be like, hey, we need this, and I need to do this. Can I do it? And it becomes a sub-team running itself. And the team captain or the team leadership doesn't need to make all the choices. They just help to approve those choices. So, for example, we have a pit crew member who is the leader of our fabrication team. She is highly sophisticated in her knowledge of assembling and disassembling mechanisms. She can fix a robot in like an hour flat. Top to bottom. Perfect. However, communication is not her strongest suit. And so we find that our team captain forms more of a relationship of communication back and forth, and then distributing that knowledge to the other sub-teams, so that that person does not need to be in the room for an hour while bickering occurs. And it becomes a smaller meeting where more can get done. 2 people can get more done than 100 when it comes to debating. When it comes to moving a piano, you're going to need more than 2 people. So pick your battles, figure out when the bickering should occur before kickoff, hopefully. Figure out some of those arguments that we had, hash it out, or reduce the number of people in that meeting. That's how I tend to solve those problems. And it doesn't get rid of those problems. Every team's going to have those disagreements where they're like, I think we should do 3-wheel swerve. There's always going to be one person who's like, what if we lose a wheel? What if we go with boring? Boring is clutch was a phrase I heard earlier on stream in this very room. And I think I'm going to start using that. Boring is clutch. I think Rishi and Shazzy wants to say that. Yeah, it's a difficult position to be in when you're one of the more dedicated people and you want to encourage people to rely on other students. But the best way to do it is to hype up those students. Show how good of a leader that student is, or show how technically competent those students are. For example, I can't code. I know how to code Scratch, I know how to code PLCs, I can program a robot arm to do a weld joint, but I cannot for the life of me figure out Java. And that's okay. That means that I rely on the students who study programming to uphold and uplift this lead. So every chance I get, I compliment our lead coder. I compliment the second lead coder. I compliment the rookie who's 1 week into code. Because that's the team I want to exemplify as here are some role models you can look up to and communicate with. Because I don't know what you're talking about, but I know that they know what you're talking about. And hopefully everybody knows enough English that we can all communicate together.
And do you have any, communication tips? Because I feel like our team is really.
Communication is difficult. I will say that, especially with the language barrier. Now, we have been getting better at communicating in different languages. I've learned to identify what low power means in Mandarin, which means when somebody shouts "me dian," I know what to expect. However, communication issues are always going to happens on Team Dave, probably happens on OP. I don't know, they're pretty perfect, but happens to the best of us. And the way we can overcome it is by being honest, humble, say what you mean. Don't try to add subtext to be either more polite or less polite. And I learned that from Asha Mills-Emmett, who was an alumni from your team. When he gave a presentation in 2018 at Swapposium, that changed how I view mentorship.
There's so many, like, I feel like there was so much lost knowledge after 2020, because 2020 was like one of our peaks. And then, like, we have Connell and we have Allison, and Allison is like didn't do much this year or last year.
I mean, she's hoping to run the events, right?
No, like for our team, I mean specifically. Like, I feel like I wish we could talk to more people that weren't Connell and Allison and like a rookie from.
What are you talking about?
No, like, they're great. No, I'm not saying. I'm saying.
No,
like,
I know what you mean, though.
And how our team was. I mean, also Ben, because he was our captain that year.
Mm-hmm.
Like, there was a reason it was so successful, but then we're so against using his method to be more successful this year. At least that's how I.
And finding a method that works for the students who are on the team now, not what worked previously, is what's going to get you out of that set.
And I think that our team is very successful this year. I just. Like, there was so much unnecessary bickering almost, because also it's like they're friends. Like, it's a couple of friend groups, but it's also like specific people arguing with each other, but then the groups arguing with each, and I don't know
it's very cliquey.
And I don't. Yeah. I feel like we don't know how to just all listen, like all talk equally or all listen as much.
Inter-bickering, is it the same sub-team? Or is it different sub-teams? Because you can then categorize and subcategorize.
It's very. I feel like it feels very random.
Random,
not
okay.
Random, but like year-based.
I don't know how much time we have to talk about.
Yeah.
I am happy to email me. You got my email. You got my profile picture. Happy to answer questions. I'm sorry. I'm going to come over here. That fan's very loud, but I'm interested in hearing what you have to say. How many team members do you have? 18? That's really good. Okay. 18 is a good start. When we were pre-rookies, we brought, I think, 12. So 18 is a wonderful thing. Are you happy to be one that do a little bit of everything, or are you happy to do a little specific? Okay, so you've got like one person who's like, I want to website, and one person who's like, I want to build, I don't want to that sort of how it is? Okay. So let me see if I can go back. This is not my laptop, so I don't know how to do it. But let's see if I can go back to the early project management side and we can talk about it. We'll avoid the perfect pictures. I hope you guys see it. Okay.
We're definitely showing
it. You can show it to him. I'm sure he's cool with it. I tried to find a picture that was from his TED Talk because that at least I know he's consented to being filmed for that. I don't want to show him when he was wearing those hats without the top in like 2006. That's not relevant, he's an expert. So in 2023, we had team management for subjectives. So this sounds more like your team. You've got a bunch of people who are separated into different puzzle pieces that vary on the technical and the hands-on side of things. So you can be very hands-on and not very technical, and that means you're on strategy. Or you can be very hands-off but very technical, and that means you're probably on autonomous or automation, which is what we call our coding/wiring at the top. This might work well for your team, but again, the best person to make this call is you or whoever your team lead is. Because Bubbles is a brand new team, you get to create your own team identity. It's a wonderful privilege to be a rookie team. Because when you're a third-year team, there's a certain status quo that's already going against the new flow of ideas. Hopefully, we as 9062 are doing a good job of keeping the flow of ideas running, but sometimes teams get stagnant. So whatever ideas you think you and your friends will work best with, is what you should try out. And if it doesn't work, you can change it next year, or you can even change it in January. If you go, you know what, we've got 4 team captains right now. Why do I need 4 people to sign off on this before I buy it through the school? Change it. Hold another vote. Change it whenever you like. Whatever works for your team. So if you have 18 people, you probably don't need 9 team leads, because then it means you only have 9 people you're leading. I would probably have 2 or 3 people in a position of leadership, 1 for the more technical build side, 1 for the coding and sensors and all that, and then 1 for the business side. 3 sub-teams means that you've got a few people to dedicate to each subgroup, and then they can split off, and your website guy can focus on the website, your coding girl can work on the automation and the autonomous mode, whatever it happens to be. Does that work? Does that answer your question? Okay, great.
It's sorry. Can I?
Of course, yeah.
No, it's something different. How do you? Okay. Do you have any like ways to encourage GP in rookies, but also mentors? Because I like. Sorry, not mentors.
Okay.
I mean, not mentors. Seniors. Rookies and seniors.
Okay.
Because like how to make it more
Civil?
civil, I guess. Like I'm not gonna.
So what I'm gathering is there's a bit of chiding going on, a bit of hazing for any new students or something.
It's
Grade
not-
12s are like, oh, we know everything.
No, it's not between them. It's like. Can I think about it for a second?
For sure.
Anyone else
Yeah,
has a question?
absolutely. We can talk about whatever Ren wants to talk about for a minute, and then we can come back, because I'm interested to hear.
Yeah. I'm interested, what are your strategies for member retention?
Pardon?
Because member retention,
Member retention. We add people throughout the year. So I normally run classes with an open lab at the same time. We have the benefit of me teaching in a classroom that the back half can be dedicated to robotics. It is a nightmare of a mess,
I'm so jealous.
but it's awesome. It's about 1,700 square feet. We've got a carpeted, closed-off room with a window in it for practicing. It's about 10 foot by 20 foot. So the window was already there. It was awesome. It's the exact same size as the drive station. Oh, I could go on and on about how awesome our lab
Very
is.
good.
The square footage is about this. The amount of outlets we have is sub from ideal. So we are finding that we are running out of places to charge our laptops, but that's an ongoing problem we're working to solve. So we're in an environment where I can have people hanging out in the back playing Smash Bros. And relaxing. And then whenever class is over, and they weren't in my class to begin with, hopefully they were in the class doing work or at least quietly playing Smash Bros. On their own device. We can then invite everybody to have a meeting where stuff gets done. So we have 5-period systems similar to how Bishop Ryan runs their school with staggered lunches. So during both staggered lunches, I'm available. The lab is open. Come and do whatever you need to do. For example, I believe, I don't think she's in the room, Helen has been working on posters for our teams for the competition. So one corner of the room is full of paint. And then we've got other people like Aisha who are working on designing their first parts in Onshape. And that can be an ongoing conversation where they come up to the desk and ask us. So member retention is actually really good because every class I teach, I have over 100% attendance. More than the class shows up. Other people tune in to either hear the stuff that I yap about for design or just to hang out and get some work done. So it creates this welcoming environment where the door is always open, metaphorically, not literally. The hall is actually very small, but it allows people to hang out in places that feel comfortable and it feels like a safe space to pitch ideas. So when somebody comes in crisis or they're super stressed about exams, we can talk about it and help them through it, and that actually boosts the amount of people who want to be here because they feel like it's fun for them. For our team, that gives me a huge sense of pride because we're a home away from home.
Okay, I think I've got it all. Like
All right, shoot.
the main issue I think for our team is that it's not like no one thinks it's supposed to be fun. Everything,
Oh. That's weird. Okay. No one thinks it's supposed to be. So people are like, "Oh, I need to wear a suit to competition."
No, it's like it's very like if you're not being productive. Like I think our whole system for next year is if you're not being productive in the lab, specifically rookies, you are not going to be invited to the lab. And
Interesting. So one way to combat that is to have it one dedicated day where you can goof off a semester. Just one. Just one is all it takes. For example, at the end of this semester, does anyone remember what we're doing? Let's see, what are we doing? Pool noodle fight day. Because every time a rookie picks up a pool noodle, what do? They try and have a lightsaber fight in the middle of the classroom. They're trying to make safety partners. It takes forever, right? And it feels not so fun when you have to be the person to be like, hey, put that down. We need to get stuff done. To encourage them, I say, hey, put that down until the last day of the semester, and then go ahead. Wear safety glasses, but sure, hit each other with pool noodles on the last day of class. It creates a fun thing we can look forward to. Because Steele's been waiting all semester for it. He's ready. He's got a strategy in mind. It's like an alarm bell goes off with our school, and it's just lightsaber fights in the classroom for one. That means every other day, there's nothing like that. We can get work done. We don't need to worry about pool noodles, because even if I'm not in the room, someone will go, hey, wait a second, it's not pool noodle fight day yet. What are you? This is against regulation. And so there's rules to the playtime that encourages stuff to get done in the meantime. Does that make sense? So obviously, pool noodle fight day is not a universal, nationally celebrated holiday, but whatever works for your team works for your team. You've got people who are always doing the thing with wrenches where they make the clickety noise, and they're just sitting there fidgeting with it. Make a game out of it. Make them have it once a month or something. And that limits the amount of goof-off time you can have while still making it seem like it's a fun and approachable thing.
I guess that's not the issue. The issue is that I feel like our team is only about productivity. And I think that's what causes.
And you're saying that potential retention and recruitment and openness is also a concern. So you could feed two birds with one stone here and solve both problems at once by providing a little bit of fun and a little bit of charm to the team. And you sacrifice one building. Whether that's worth it or not is up to your team, because your team is pretty good. You've got a lot of technical knowledge. You generally go for rank points and points simultaneously. You tend to opt for a climb as well. So you're doing a lot of things during the season. But factor in the student fun first, right?
That's just
We're here on a Saturday. We're not here because we think it's the right thing to do. We're here because we thought it might be interesting, we thought we might want to learn something, or we thought we might have fun with our friends and make some movies. Right? I feel like you're in a tough position here with 865 that you're trying to provide a very professional reality when these are teenagers.
Yeah, I feel like it's just such
And then some of those teenagers go and work a job as well, right? You've got some teenagers on these teams who have to go and provide for their family or provide some spending money for themselves by working an actual professional job. Mm-hmm. Why make this be a job? This should not be the job. This should be the reward. After you're done work, you can go and hang out at robotics. Yeah. I don't know. Maybe I'm the crazy one, but I've heard about that quite a bit in other teams, in that we have a dress code for this team, we have everything that we need to get done, and our school has a dress code, but we keep the status quo. We don't go above and beyond to make it more formal. Mm-hmm. We try to lower those barriers so that it seems more welcoming, and it means that I've got the problem of supervision at events, not enough members. Mm-hmm. I need more parents. I need more people to look at these students, because I've got 60 of them. It's a great problem to have. I love having that problem. I would much rather have that problem.
It is I feel like with our team as well, it is about people stop showing up because they're not doing anything, and that's what we're improving on this year. But also, if you're, I guess it's more something I gotta bring up with my own team, but I just don't know how, because they're very set on doing, not having, I don't think they're not having fun thing.
So maybe you can take a quick check-in with other teams that have a similar caliber, a similar EPA, whatever your unit of measure you choose. Look at the teams that you are like, look at the teams you want to be like. Figure out what their ratio of play to work is. How much goofing off with the game piece do they get on day one of kickoff? As soon as you get the game piece, what's the first thing that the average rookie team does? Oh, look at this! Oh, that's a lot of fun, right? It encourages playing with the note, understanding the mechanical characteristics. Think about that play as work. Then you're like, oh, what is the structural integrity of the note? At what ratio can I bend this? Or just go, I wonder how far I can bend this before it breaks. Oh, it broke. Then now we know. Those are the same task, just with a fun spin to it, right? It's a matter of perspective, not what you're actually doing. So it sounds like you're doing the right thing. You just need to change the mindset about how you do it. It's like I said, you're a good team. You've got good leadership. You've got great examples for mentorship. I mean, look at Robin. Robin's a great leader, and so is Katarina. So is basically every team member I've known on your team. That they're all respectful, professional adults.
I agree with that. I'm saying like those are like peak members, and I feel like a lot of our
But it's every member I know, so it
No.
doesn't seem like peak to me.
no, but that's the thing though. It's like I'm one of the only one of our members who like actually goes out and talks to other team
Mhm.
members, like other people. Like I
Yeah.
am one of the only people on my team that has other contacts or youth. Like I'm youth council. I'm the first like person on youth council in whatever 4 years.
Congratulations.
Thank you. But like,
They literally clapped in the other room. They heard that and they're like,
because I put in the effort to like talk to other people. I just don't, and my team seems so against it. I don't.
that it sounds like it's a more serious conversation to be had with the leaders of your team. What do you want the vibe to be like when a grade 9 walks into your class for the first time?
Like,
You want it to seem like they could find themselves on that
yeah,
team.
because also like when I joined my team, I was so scared. Like the second I walked into the room, I basically walked out immediately after. But I'm really stubborn, so I kept going back.
I do get a few of those, but usually that's because they think my lab is IT, and they walk in to help with fixing their MacBook, and they go, "Oh, I don't see a MacBook in here." But I am happy to converse with you more on that over email or whatever format you prefer. Happy to get Mr. Wang involved. Let's talk about it. Look, I recognize that it is also coming up on 3:30. 3 p.m. And we've been going at this for 90 minutes. Thank you very much for your participation. Does anyone else have any other questions before we get going? All right, well, thank you so much. This has been a wonderful opportunity to speak to you. Thank you very much to 2056 for hosting this live.
Go ahead. I'm probably gonna